My name is Jason Sturges. I'm here to talk to you a little bit today about Mazak and the AI and the new features that are with our smooth control and all the technology that goes along with that. So just a little bit about myself. I've been in the CNC industry about 15 years. Worked in a job shop for about 12 of that. Operator, programmer, setup guy, lead man. Now as an applications engineer for Mazak, I help people try to accomplish their goals of what they're trying to do with our machines. So kind of seen this from all different angles as far as this industry goes, as far as CNC goes. And what I've got for you today is hopefully some things that'll be good for operators, some things that'll be good for programmers, some things that'll be good for shop owners as well. So we'll get into it too right here. So for 40 years, Mazak has been making conversational CNC for lathes, right? And what are we talking about when we're talking about conversational? It means there's no need for programmers and operators to memorize G&M code. Every time they program, they don't have to go and open a manual to see what codes they need. They don't have to memorize it all. The machine is simply going to ask you questions, and you give the machine answers, and the machine will create everything for you. It eliminates the need for CAD/CAM systems for simple parts, right? So you don't need everyone to be trained on how to run a CAD/CAM system. Right there at the controller, within minutes, you can create a program for simple parts. Ease of editing at the machine. Okay, so always happens, we have a part we've run for years, we get a revision change. For whatever reason we need to make any change to the program, normally what happens is you need to run that back through your CAD/CAM system, repost the whole program out. What happens is you've lost all the editing that you've actually done at the control, right? So with Mezatrol and conversational programming, it's just simply a couple keystrokes right there at the machine. We'll take care of that. It allows you to train new operators in days and weeks rather than weeks and months. It's a very simple system. As I said, the machine asks you questions and you give it answers. So just real quick here, this is what a smooth AI conversational interface would look like. So if you see down here in the bottom right corner, it says machining unit. So at the bottom there, I just need to tell the machine, what do I want to do? Do I want to thread apart? Do I want to drill apart, groove apart, or bar out or bar in, some general turning or boring? So I just filled in right there, bar out. Now down in the bottom right corner, it says, well, what's your cutting points? We'll start at 5 inches on the diameter and at the face of the part at 0. Do you want to leave anything for your finish allowance, for your finish tool? I put in what I want. The machine will automatically populate some tools for me based off of what is already in there. It's a recommendation. You can change it, edit it if you want. But even more importantly, it'll pull up this box down at the bottom, which shows you all of that type of tool that is currently in the machine. So if you don't remember, if you've got a 72 tool magazine and you don't remember if you need 26, 32, or 68, here it is. It says all the general outs that are in the machine right there. I can simply touch that on my touch screen, select my tool, and fill it in. We've got a couple different cutting patterns for you. And then I just simply put in a depth of cut, my cutting feeds and speeds, and that's it. So I just want you to kind of look at all the detail that's been taken care of there that a person could do in about 15 seconds. They've told the machine where to start cutting. They told the machine all the cutting data that it needs. They told it what to leave for the finish allowance, and they've selected their tool all right there already. So now we get down to our geometry is the last thing to do. What shape do I want to cut? So down at the bottom, you can see I've got options of a line, a taper, or a concave or a convex arc. So here I put a line. What's very nice here, if you want to put a start corner, a radius, or a chamfer, or something like that, I don't have to write a line of code for that. I just tell it, in this case, put a 20-thou chamfer right on the front of that. The machine takes care of it for me. Finish point X, finish point Z. Where do you want this line to end? Put those numbers in. And then over here on the right, I can also attach a surface roughness to that. I don't need to break out my calculator and know how to get a 16 micro inch surface finish on something. You know, I can just put in a diamond 6 there, and it's going to come out right. Next, if you want to do a taper, you know, the taper will start right where you left off. And if you don't know exactly where this thing is going to end, if you have 3 numbers of an angle and you have the angle, the machine will compute the 4th number for you. It'll pop it right in there. And that's that. We just programmed a bar out, right? So anybody who has run this machine or had some training on this for a week can do that. in under a minute probably. So that's the kind of speed, that's the kind of productivity that you can get out of this. What's even nicer now on our smooth control and on our smooth AI control is as I'm programming every single unit, the machine is creating a solid model for me on here, right? So there's the shape. If I put in a number, I missed a decimal point, so put in 3" instead of 0.3 inch, I'm gonna see it right here on the model before I start running the part and it comes out looking bad or it makes a lot of noise that the boss hears from the other side of the shop, right? So that's a very nice feature they've added on there. And also, it'll shade it in purple here. It'll show you actually all the stock removal that you're gonna do to get there, so you can make sure you're not kind of crashing through your part where stock hasn't been removed yet as well. So, you know, what our conversational is, if you look on the right hand here, you can see all these G codes and M codes up there. These are all the codes that are modal while this program is running. So just because it's a Mezatrol program, the machine is still running on G and M code, just like every other CNC machine in the world, right? What the Mezatrol is an interface that allows you and a lot more people to just simply answer questions and let the machine in the background fill in all those answers for you as to every movement the machine needs to make. On our AI, what we've added is a comment unit. So some of these programs can be hundreds of units long, right? You can have multiple drills, multiple taps, multiple turning units. And so if you're trying to restart somewhere, you need to go in and edit a unit. You don't know which one it is because it can all really look the same. So now we can put a comment in our program, like on here they put head 1 turning. And actually while you're running the program on your main home screen, you'll see that head 1 turning pop up. So you can always see where the machine is at, exactly what it's doing. Instead of just having a particular unit number or something, it's going to tell you exactly where it's at. One of the features that we really like right now is we basically added, you guys run G code programs, G and M code programs, right? So in Mezatrol, we never had like a block skip before, right? Now we do. We can simply go and on the box on the right, you can see that unit's kind of, it's a gray color, whereas on the left, it's a blue color. You can go in, we call it control out. The unit will stay in the program, so you don't have to erase it. You don't lose the data, but the machine will act like it's simply not there. It'll just skip over it while it runs. So very handy to have that. So something that came out on our smooth control is, you know, Mezatrol's been trying to move in the way of getting some CAD/CAM features mixed in with it. So let's say I needed to mill this shape right here onto the OD of a part. That's a lot of points to figure out, right? You could go to your guy, you know, the guy that did the drawings where the shop I worked, the guy was in the next building. So it was okay in July, but in February it kind of stunk walking over there to have this guy get a drawing for me with all of these intersection points on there. So what we have now is a feature called 3D Assist. And what 3D Assist allows me to do is load a solid model directly into my NC control, and then I can take the geometry directly off of the model. So here you can see the model's been loaded in. We got a workpiece coordinate on there. And kind of similar to a CAD/CAM system, what I can do is I can just create features and I can create chains. And this is all right on your touch screen, right? So you just touch the beginning of the chain, touch the end of the chain, touch the feature. And what will happen is it spits out all of my coordinate information for me. All of my geometry is in there. So number one, much quicker. Number one, nobody has to do the math on all this stuff. And number three, we know this is accurate because it came directly off of the model, right? There's no chance that someone put numbers in wrong. There's no chance that somebody missed a decimal point. There's no chance that somebody did the math wrong. The numbers are coming directly from the model, so we know it's very accurate. So that came out on the smooth control. So when the smooth AI control came out, they upped the ante a little bit. So what we have now is a feature called solid Mezatrol. And this is where it will generate a complete program from a solid model, okay? So I'm gonna scratch the surface on a lot of this stuff. If you guys like any more information, Mazak booth is right over here. I'll be more than happy to walk you guys through some of this. But basically, I've got 5 steps in this scenario here. Number one, I load in a solid model. You can get it off the hard drive of your NC computer. You can get it off a USB that you plug in, an SD card, wherever you keep that kind of stuff. We'll load in a model. You can see that the model was loaded in there. So, you know, I've been asking people all week with this, you know, how long would it take you to program that? I've heard anywhere from 6 minutes to 4 hours, right? I think probably accurately it would be about, maybe an experienced programmer, maybe 40 minutes to an hour, let's say. So what we're going to do now is we have to create a workpiece. So on the left here, every workpiece that has been entered in here before stays in this library. So if I do a lot of repetitive work, I don't have to create a workpiece every time. I can just go in here and simply select the one that I want. And you can see the kind of the yellow wireframe there is the workpiece. And now it kind of creates it as a model. So second step's done. Third step is I need to align this workpiece with this model. So for the most part on a turning machine like this, I can simply hit the auto button on there and it lines it up correctly. This particular machine had 2 spindles, so if I want to do the other side as the first operation and kind of flip it that way, that's what the Z reverse is for. And on any odd shaped castings, I can choose a diameter to put on center line of my lathe and it'll work everything off of there. So that's the third step is done. So you're already halfway done to just getting a program off of this model. So now here's what it comes down to. They give us a nice cross section of this part here. And what I need to do is tell it on my outer features, how far do I want to go on the first operation and how far do I want to go in Z on my second operation, okay? So you can see the yellow arrow up there. You can do this with the touch screen. You can just touch anywhere you want. You've got some arrows on there. You can just hit the arrow and it will go from shoulder to shoulder to shoulder, or you can simply put in a number. If you need to go 3 1/4 inches, you can just type in 3 1/4 inches there. This is metric. The part's not actually 99 inches long. Came off a metric machine. So I just need to tell that on head 1. And then also on head 2, I need to tell it back with the yellow arrow coming the other way, how far do I need to go with my OD features there. Then I'm going to do the same thing with my ID. You got the gray arrow there. That's where I want to go with on head 1 with my ID. And then on my head 2 operation, I'm going to come back the other way to the same place. Now, we got a lot of holes in here. So we may have features on here that need to be counterbored. They may need to be reamed holes or tapped holes. Maybe we need to turn threads, things you don't always see on the model. So we do have a spot where we can take care of all this. Basically, I can put an attribute on here, and it tells it, like down here, we've got a reaming or a boring. I can select that. I simply highlight the hole on my touch screen. I tell it what I want it to do, and now it's going to actually create a unit to tap, or a unit to ream, or a unit to bore, right? It's going to create center drill, drill, tap. It's going to create center drill, drill, ream. So you're telling the machine, what units it needs to make this part. Surface roughness, again, I can simply highlight on the model different surfaces. Maybe some are getting ground and I don't need to waste time getting a very fine surface finish. Maybe some of them I do. So I can put different surface roughness on different features. I simply hit OK down there at the bottom. And this is where it takes time. So this part actually on our simulator right over here took about 3.5 minutes to generate the program for this part. So we just talked about taking an hour, 40 minutes an hour. About 3.5 minutes, it's going to create all of the Mezatrol units for this part. Now we can see all our units here. If I want to reorder units, say I want to turn it before I drill it, or I want to copy this, I want to run a finish pass twice, I want to copy a unit, edit a unit. I have that option before it generates the program. And as you go, you can see here the T drill face is highlighted, so it's going to show you exactly what the drill is going to do as well. I hit OK there, asks me for a program number, and it takes about 2 seconds. It generates the entire program for this part, right? Has WPC units. It tells it head selection units, indexing of the turret, chuck transfer. Everything is in there. You may need to go in and select exactly which tool you want for some operations. You may need to go in and put in some cutting conditions, your cutting feeds and speeds. But other than that, this thing will be ready to go. So here again, we want to talk about what the AI technology can do, saving you 45 minutes in programming on this part. Number 2, everything was taken directly off of the solid model. I think this program has like 150 units to it. The odds that someone does some bad math, puts a number in wrong over those 150 units, happens every day. We've all scrapped parts because of that, right? So accuracy and time savings right there with the AI. Now, common misconception with Mazak is Mazak has their own, they got this Mezatrol stuff, right? They don't run G-code. We've been running G-code for like 45 years on our machines. We run it as good as anybody, right? So we've also, on the AI control and on the smooth control, kind of updated some handy stuff that we can do there. We still have a lot of people that do a lot of hand editing and can cycle G-code programming on their machines. So what the Smooth AI control did is it said, all right, I can open up my tool data window right here. I've got a 72 tool magazine. I don't remember what number the tool is. I can just scroll through there until I see what tool number I want. I can select it. I can hit the M6 button, and it will add that tool change right into my program. Same thing with can cycles, or fixed cycles, drilling cycles, turning cycles. You know, I can never remember, oh, I'm doing a G83. That's a some kind of deep hole drilling cycle. I can never remember what Q means or what P means or what R means. Now they have all that for you right here up on the top right box there where it's got the G83 in there. You can see what happens is it has all the addresses right there, X, Y, R, Z, Q, F, but it has a description of what each one is right next to it. So now I know what it is. I know what I need to put in there. And as I write it, it's creating my program line at the top, and it puts it right into the program for me. So custom EIA screen. Finally color-coded these things like our G-code editors have had forever, our Simco and everything like that. You know, different colors for G-code, M-code, tool change, sequence number. Makes it much handier when you're trying to, than when everything's just all the same color in there and you're trying to decipher, you're trying to find some very specific things in the code. So now with the EIA, we've got what's called Quickeia. It's a pretty cool feature here. What it does is on the left part of this box, on the top left, it kind of sorts out some ways for me to jump through the program real quick. It'll go through by rapid or feed modes. It'll go through by, they got an example in here, a G5 high speed on, and it'll just kind of allow me to search right there. It'll take me directly to those lines of code. Some of these programs are like hundreds of thousands of lines of code, right? You don't want to have to sit there and do this for 5 hours on your touchscreen, right? It's an easy way to search and get in there. Now on the right, you can see all these green lines. It's actually creating the toolpath. This looks like they had some sort of blade, maybe I don't know, a turbine blade or something in there. But what I can do is I can enlarge this and I can touch on any one of those movements in there. It will take me to that line of code. Okay, so if you have a toolpath and you see that something just doesn't look right, it'll take you down to line 53,265 where that movement is. You can say, okay, yeah, that's what's wrong there. So very powerful tool, very easy way to analyze your toolpath and be able to play with your code. The other thing we've got is this surf analyze. It'll analyze your toolpath. It'll highlight directional changes. When we get into contour milling, freeform milling type operations, you know, the directional changes are very important. That's where you lose your smoothness. You have to accelerate and decelerate around these curves correctly. So there's a way to just identify all those, look at those, go right to the code. Macro comment. Anybody do a lot of macro programming? Right? You know, you get in there and you're writing to variables. Say your probing is writing to variables, and I never remember, is it 503 or 505? Is that the one I'm supposed to look at the number for, right? Now you can put a comment right next to every single macro variable and you can label it right there. So when you go to that screen, you go to your 500 variables, it's telling you on each one exactly what it is. So very handy. Just keeping in times with all the computer stuff here, we've got a screen history now. So instead of having to hit the left arrow, the right arrow quite as much to change back and forth on screens, it's gonna save your last 3 screens right there, as well as your apps manager. So Smooth AI is a CNC control fused with a PC, right? So you have applications that are stored on your PC that actually run on the NC. So all those will show up here. If you guys do Renishaw probing or set and inspect or things like that, that app will always be right here, okay? And we also have our manuals on there. So anytime you're stuck, you can just open up a manual right there on your control. You can do like a control F search, keyword search through there, and find things very, very quick in your manuals. Program override check. So it used to be problems in the past. If you loaded in number 4 off of your USB and there was already a number 4, it would overwrite it. You lost your program. So now what will happen is any numbers that it sees that you're trying to load in where there already is a number, the screen will pop up and you can say, yeah, it's okay to overwrite these, but not these. Okay, so just safety, making sure you don't lose your programs. So just kind of sum up some of this stuff up. You know, the Smooth AI is the fastest CNC computer in the world. That's a fact. Substantially reducing cycle times and also reduced programming time, reduced setup times because of all this. The touchscreen functionality saves a ton of time between changing screens all the time, having to slowly arrow down through things. We've got advanced conversational and EIA programming. Both of those have been greatly enhanced from the Matrix controls and the Matrix 2 controls. The ergonomic design, the touchscreen is great. Everybody loves it, right? I find myself, after being in the shop all day, I go to my computer and I try and touch my screen. It doesn't work, right? You get so used to it. And connectivity. You know, a lot of data collection coming off machines now. We want everything to be hooked up to our networks. We had a guy from Mazak here yesterday. He's one of the leading MT Connect people in the world. The guy wrote the MT Connect standard for machine tool. So all our machines are come standard now out of the factory. Our Smooth AI machines ready for MT Connect. So when we talk about smooth machining, they named it smooth for a reason, and that is the smooth machining configuration. And what they really did was they stepped up. So many parts now have freeform milling, contour milling type operations involved in there. So we have some features in here to just make that better, to make it easier, and to make it simpler to make adjustments, right? So the first one is called smooth corner control. And that's gonna make sure that if you're coming into a radius in a corner while you're milling, it's going to accelerate, decelerate, so that it keeps the smoothness without gouging in or digging around. But you also have to hold size around there. If you're going too fast, you're not gonna be able to hold size all the time. The variable acceleration control, that's kind of goes along with that, kind of doing the same thing. Ultra high speed machining mode. The industry and the standard, I should say, that computer is reading 8 blocks ahead in your program from what it's currently running. It's always reading 8 blocks ahead. Now with the Smooth AI, we're reading 16 blocks ahead. So we've doubled that. And what that's going to do is it's going to make out for smoother curves because the machine is looking farther ahead to figure out how to put all these little micro segments together, right? And rapid overlap. Let's say you're drilling a series of holes, right? The drill used to come down. It would come up, over, down, up, over, down. I call it boxy, right? Now what it does, it just finds a nice little arc to go from thing to thing. So what we do is you have this SMC screen on your Smooth control or on your Smooth AI control, and there's settings that come preset from the factory, and you're going to play with a couple of these sliders that are on there on your touchscreen. You're going to say, how important is accuracy on this part? How important is the smoothness on this part? And how important is the cycle time on this part, okay? So sometimes maybe you can give on accuracy, but you're worried about the time. Sometimes the finish is most important, right? So what you do is you just play with these sliders, and what it does is it's temporarily changing parameters inside the machine. Feed, forward, gain type machine parameters, all having to do with all the servo motors and everything. Just for this operation, you'll assign an M code to that setting. You call the M code up in your program. Now the machine is running on those parameters temporarily while it's running that operation. Then you turn it off, you go back to normal. So that's really at the heart of what the smooth machining is when that came out. So couple features on here. This is simple, our program file. You probably see this all the time. It's your whole list of programs loaded into your NC. We do, if you look under where it says standard program up there, it says HDD operation. A lot of people don't know about this. I can store programs on the hard drive folder on my C drive of the PC type of this computer. The CNC will go find it when it needs it, right? You can take all the Renishaw has like 40 programs on there for your probing. You can take those and put it in the HDD file. They're out of your way on here. You don't have to scroll through them anymore. And the machine will go find them as you call them up, right? They're out of sight. But what we also have is a project folder. And what this allows me to do is say, if I had 80 programs on there, it gets messy. Let's face it. So what you're able to do is create folders for different projects. So for example, I have a customer that what they do is for every customer that they run parts for, they have a folder, right? Acme Industries, like Wile E. Coyote, right? He's always got the Acme Industries. You can have Acme Industries folder, and every program that you have in this machine that is for an Acme Industries part, you simply put it in that folder. It takes it out of the big list, right? So that's gone. And now when I'm going to run a part for them, I simply highlight that folder, and only the programs for their parts come up, right? So it's a way of just maintaining without this list getting way out of hand on you. So in here, so I've got the Mazak program, and only the 4 programs out of that whole list that was on there before, only the 4 programs I put in that folder show up on my program file there. So with all this stuff, all this capability, sometimes people can know just enough to get dangerous, is the expression I've always heard, right? You don't necessarily want everybody being able to do everything because people can get in there and they can change stuff. So Mazak has come up with a feature called Data Guard. What that means is you take any employee who's going to run this machine and you rank them from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. And for each rank, you assign what screens they can have access to. Okay? So if you don't want someone being able to touch a program, you lock them out. If you don't want someone being able to change parameters, you lock them out. Maybe all you want them to do is be able to make wear offsets as their shift goes on, right? So what you can do, for example, here I'm on tool data. I can have someone be able to do the wear comp over here on the right, but not do anything else on the tool data page. So it's not even all or nothing with a page. I can get down to every little field on every single page on this machine and allow them to or not allow them to. So when they come on the shift, it looks like it does just here on the right. They go change operator. They have to log in with their user and password. Now you also know what happens when who's logged in when everything happens too, right? So that's a great thing. As I mentioned before, the manuals are right here on the control. You just go to your apps manager, you pop them open. Now you've got a PDF document right there on your CNC that you can search. If you need a quick M code, you got an alarm, you're not sure what it means. You can be right there in the manual looking at it within 45 seconds. So now we can take all of this, and this is where some of this smooth and some of this AI technology comes in. We take all of this stuff that's in that control, and I can be sitting on my laptop working on it. I can be sitting at my desk working on it with what we call Mezatrol Twins, right? It's a software package that we offer. I can simply put a USB in my machine. I offload the cam data onto the USB. I load it into the software. Software can have hundreds of machines in here. If you got horizontals, verticals, integrex, lathes, everything. You can have every single machine in here. And what that data is it's a snapshot of the machine at the moment that you take the data. It's going to have the exact tool data that's in there. It's going to have all your programs. It's going to have your parameters as they're set. It's going to have your macro variables. It's going to be like standing at that control at your desk, right? So if we get into offline programming or things like that, this is what we're talking about. I can create programs on here, put them on a USB, go out and load them right into my machine, right? Very, very powerful tool. The other thing that the software can do is we can go from our Smooth AI, our newest control, all the way back about 5 generations to the Fusion M640 controls. I can convert programs, okay? So I can offline create a new program right here on Smooth AI. And if I have, say it's a horizontal machine, if I have a horizontal machine that has a matrix control on it or has a Fusion control on it, in about 45 seconds, I can convert it to the format for Fusion, load it into that machine, right? And you go the other way. You can actually take the older and come to the newer as well. So very, very powerful tool. We talked about data collection a little bit earlier. We also have a software called Smooth Monitor AX. I kind of had an example of this over there on our simulator. I stole it because I took my computer over here. But MT Connect data collection, that's where everything's at these days. This IoT, OEE stuff. So what Mazak has done is they've created a dashboard instead of you having to necessarily go out and maybe find a third party to create your dashboard for you. They've taken 8 or 9 of probably the most used things of data that people have been collecting out there, and we offer it as well through the Smooth Monitor software. Just a little example here. I'd had this on my computer on our simulator. I was actually monitoring a couple machines in our factory in Kentucky through the internet, right? So I was watching machine Web 5610. It's a horizontal that's making turrets for lathes down in Kentucky. But I can see, on Wednesday, August 7th of 2020, that machine was in alarm 128 outside interlock axis. I can see how long that was in that alarm state for, actually. So if you're having problems with production, you can just watch what the machines are doing. Hey, it was in feed hold this long. It was in alarm for this long. You can iron out a lot of problems that way when you see what's really going on.